Good morning, everyone. And in the last class, we have seen about electromagnetic radiation and electromagnetic spectrum. Before we are going to discuss about this electromagnetic radiation and electromagnetic spectrum more in a more understandable manner, I would like to go to the previous topics what we discussed in the previous online sessions because the foundation has to be strong when we are moving forward to the topics. So, as you all know that, I think by the time you follow two online sessions, you are well aware what is remote sensing, what is the prime use of remote sensing, and what is the process involved in the remote sensing. Hope you all are aware. I think you all enjoying the classes with this new technology, and in somewhere other way, you may be well familiar with this technology, and it may be encountered while you are watching movies or while you are following in any crime investigations. Because it may be observed in certain situations, the GPS technology plays vital role to find out where the required object is. And I said that maybe in the days to come, already the technology even now available, in the days to come, the technology will be very close to each and everyone. In a classic example, at the time mobile was invented, only the people who can afford the incoming calls and outgoing calls, they may have these mobile phones. Nowadays, mobile became part of like currency, part of like money. Whenever the people are going out from the homes, if or else they may forget whether they have currency or not. They may not check whether they have sufficient money or not. But people are very much cautious while they have mobile phone or not, while they are going out from their respective homes. That means what I'm speaking is here, mobile phone plays vital role in our daily day-to-day life. Why I'm speaking about this mobile phones here is there is a link, there is a sensitive link between these mobile phones and what we are teaching right now. Sometimes, if you are not tracked by your relatives or your loved ones, you may be tracked with the help of your mobile phone when you are missed or you are missed by somebody. That means the chip what you are having in your mobile phones that will keep you in the track and that will make you to watch over where you are on the earth. That means here the technology plays vital role, and technology is the only domain in the days to come on which the world is existed. When we are speaking about the technology point of view, remote sensing will be the first and prime technology where the entire world is running and our entire world is depending. I told you with many classic examples in the first session itself. Nowadays, every country is competing on other country to show their credentials that they are most advanced and most efficient than the fellow countries or than any other countries. In the name of increasing advanced science and technology, or else in the name of increasing science and technology, they have to depend on the technology like remote sensing. Now, remote sensing plays and remote sensing applications emerges in all the domains, including agriculture, including medical, where not everywhere. See, with prospective civil engineering perspective, I would like to speak a few points here. how the technology, this remote sensing technology, became more advanced in the lives of civil engineering people. In the days see here, in the olden days, maybe before 10 years back, or else just 10 years, 1 decade back, when the students whoever joined in civil engineering curriculum, while when they comes to second year, or as per their curriculum, they need to know and they need to learn surveying. They need to learn the surveying of an area. In those days, students and even the teachers now, they maybe learned this surveying with the help of chains. Now, the chains are the whole topic, and era of chains gone away. The chains are replaced with GPS technology. The same way, the technology is emerging in all the domains of educational sector, or else educational fraternity. See, what I'm speaking is here, the way chainsaw became history, even you may be observed sometimes, especially in this rainy season, monsoon season. We may be here when we were in a childhood, we used to hear and we used to watch certain scale measurements at bridges, and we used to hear from the televisions the water level at the bridges crossed the permissible levels, and the government announced nearby people, and government made the surrounding people to vacate, and they may be migrated, and they may be they may be scattered into the places where they can escape from the all the such type of floods. Because what I'm speaking is here, the scale measurements are giving the information about the depth of the water. Nowadays, you need not go to those scales, and you need not to depend on those such type of announcement at all. Simply, the water level is just a click away, and by you can understand what is the level of the water, what is the depth of the water in one particular body, or as per your requirement. That means the technology makes everything simplify. Instead of chains, just using GPS meters, and you are able to survey the land, you are able to measure large area of land within a short span of period, and you are able to know the depth of water bodies in a very simplified manner. That is the reason, see, as part of even your civil engineering and even our civil engineering perspective, you need to know what is the ABCD of this remote sensing. You need to know how it was developed and how it is going to play a vital role in the days to come. See, we discussed what is the introduction and how it entered into the world. We discussed as part of humans era, as part of human successful era in the name of technology, we keep on learning new things. I told you in the previous class, just years back, this is the first time in India, almost most of the almost not almost most of the I mean almost I mean not almost here, all the colleges, especially in Andhra Pradesh under JNTU, started academic calendar through online. This is the first time, and we never heard online classes when we were growing up. That means the technology brought you and me into a closed scale where you can contact each other and where you are going to learn new things, this technology. That means there is a need and there is a more important to upgrade with respect to technology. And whatever the technology may be learned or not, certain technologies like remote sensing and any other related other required technology, you have to have the knowledge. Then only you can survive in this world. See, remote sensing we just defined as it is a science and art of obtaining information. What is remote sensing? It is in science. What is science here? What is science? Science means we can define the science as set of proven things is called as science. What we can you and me can call it as science. Science in the sense set of evidences. It is a science and art. Art in the sense, it's a here, it's a science and art of obtaining information of any object, any area without physically contact to it is called as remote sensing. Now you know that here we are able to sense. See, in the olden days, whatever you want, see, somehow the technology being upgraded, in the era of upgrading technology, when we have a look over there in the past decade, people who used to communicate through letters. Just before the letters, people used to communicate each other with the pigeons. Just whatever they want to convey, one letter will be knocked to the, neck of a particular pigeon, and it will fly off, and it may reach to the particular person. There, they may be noticed what they want to know or what the other person is speaking to them. See, it depends on completely the characteristic of that particular pigeon. Later on, those pigeons are replaced by postcards. Postcards are replaced by telephones. Telephones are replaced by mobile phones. Even mobile phones are going to replace with new technology, maybe very soon. See here, that means what I'm saying is here, it is a science and art of obtaining information of any object, any area without physically contact to it is called as remote sensing. See, many times I used to give the definition of remote sensing, but I am sure that you may be, when you are listening this demo, listening this definition, you may be confident that I know why Sar is speaking again and again. But here, if you are, you may be sometimes you know, but at the time anyone asks you, you may not give the perfect definition. That's why I would like to give the definition more and more. Keep in mind, it's a science and art of obtaining information of any object or any area without physically contact to it is called as remote sensing. See, what is geographical information system? As we are in introduction classes, I need to ponder on those two words, remote sensing and geographic information system, more extensively. What is the difference between remote sensing and GIS? Here, the output of remote sensing is nothing but GIS. The output of remote sensing is input to GIS. The output of your BTech certificate is input to your survival. Without your BTech, there is no survival for you. Of course, without BTech, in the sense you can survive in number of ways, but you are studying as you are learning, and most of the people depends on the certificate for their livelihood. Of course, there are certain category of people, they may not, the certificate may not give proper settlement, because already they have their own. They are plenty enough what the future is holding for them. See, what I'm speaking is, whenever the people are doing such type of technical courses, they want to do job after their courses. For in their perspective, I am speaking. The BTech certificate is see, input to your future. That means remote sensing is input to GS. If without BTech certificates, there is no future for you what you are aspiring. Here, without remote sensing image, there is no meaning of GS. I told you in a classic example in the first slide and first session, remote sensing is just like username, and the geographical information system is password. Without username, there is no meaning of password. Without password, without username, there is no meaning of password. That means this remote sensing and GS both are interdependent and interlinked. So here, how the technology existed already we discussed. Every time I used to keep all the slides, whatever we discussed in the previous sections, because by seeing them, you may be understand what you may recollect what we discussed in the previous classes. But somehow, as we are at introduction classes, I would love to give what is the basic process that is involved in remote sensing. See, simply I told you, for suppose, as in I see now you are using laptop, see, maybe you are using mobile phones, there is in a technology active desk, because if your computer is not working well, your complete screen will be taken into the authority of the one who is repairing, who is sitting in, maybe is far away to you. Maybe if he is in Bangalore, and if any problem with your system, by simply by by what installing an app, active desk, your desktop will be controlled to the person whom you want to authorize. From there, your desktop can be repaired or else can be monitored. What I'm speaking is, in the same way, you are here and your desktop is operating by the someone who have given, you have given the authentication. That means he is not physically contact your desktop, but is operating. That's what remote sensing in a daily example. See, without physically contact to it, getting information. What type of information? The science, it is in science and art of obtaining information. Without physically contact to it is called as remote sensing. Now, what to perform the process? What are the requirements? We have already seen there are 5 components: energy, target, and sensor, atmosphere, processing stations, and analysis techniques. See, this is what we have seen in the previous class: basic components of remote sensing. And I'd like to go to that next topic, or else I want to touch the edge of the topic what we discussed in the yesterday class. Hope we were at electromagnetic radiation, and I think that I'm fully confident that you learned and you are aware what is this electromagnetic radiation, because I had just given in the previous class itself two or three times of repetition. But I'm personally feeling that once again it's my responsibility to just make you recollect what is electromagnetic radiation, because you may have in your own thoughts, sir, that was in the previous session. I forgot. Can you please explain one more time what is this electromagnetic radiation? Of course, majority people are remembered, majority people are aware, but minority people may not remember what we discussed. See here, electromagnetic radiation. Electromagnetic radiation is the energy source, that is what, and that is the only parameter through which sensors will be influenced. What is the source of electromagnetic radiation here? Electromagnetic radiation, the source of EMR is sun. From the atomic particles of sun, it enters into the real world. From there, before see, from there, once it enters to the atmosphere, it touches, or else it is coming to contact to the earth surface, as well as into the atmosphere, earth's atmosphere, and finally it contacts to the sensors. This is what about the electromagnetic radiation diagram. See, whenever you have a question, write a detailed notes on electromagnetic radiation, you must draw this diagram. Keep in mind, I don't think that when we can draw, when we can attend all these type of examination, the situation is like this. And yeah, how, when can I expect to attempt this examination and all? When future will take care of future, but you must learn all these things. See here, try to, after this session, try to draw the diagram of this electromagnetic radiation, so that you may be remembered, strongly, and you can recollect it whenever at the time of need. See here, electromagnetic radiation, simply I told you, and I just given 6 basic characteristic features of electromagnetic radiation. And first thing is, it propagates through the atmosphere, vacuum of space, and it travels within a speed of light, and it consists periodical distribution of electric field and magnetic field. And see here, and the basic characteristics and basic functions of this electromagnetic radiation is: number one is wavelength, the other one is frequency. What is wavelength? See here, periodical distribution of electric fields you are observing here. The distance between two successive crests we just discussed as wavelength, and the number of cycles that are passing from one fixed point at one particular time is called as frequency. See, whenever you have a question, you must write and you must draw this diagram, and you must give all the features. We must write all the characteristic features what we discussed right now. See, coming to that, what is electromagnetic spectrum here? Here, spectrum in the sense, electromagnetic spectrum. See, I told you that electromagnetic remote sensing is always work with respect to the reflected energy. Sensors will work only with reflected energy. See, hope you understood. That is the that is the worst highly requirement, and one of the major and basic requirement of sensor is electromagnetic radiation that is being reflecting from the target. Without recording the reflected energy of the target, the sensors won't. We can conclude that the sensors won't. The sensors are not responding when you are giving authentication, when you are trying to initiate. If the energy is not recording by sensors, either you are not initiated, nor the sensors are not working well. That means electromagnetic radiations once hitted the target, that has to be go back to the sensors, which that energy consists the characteristic features of the target. Once the EMR is recording in the sensors, that will be stored with the different wavelengths. Understand? Light is not in a single constant. It is a mixture of waves, and it consists number of wavelengths. It consists number of wavelengths. Same way, electromagnetic radiation, whenever the EMR is being stored or being recorded by sensors, it will be stored as an with respect to the wavelengths. Those wavelengths are being brought together and trying to make an attempt to onto a plane sheet. It gives electromagnetic spectrum. That's what we discussed in the previous class. Understand? See somehow, what is this electromagnetic spectrum? How they're how they constitute an electromagnetic spectrum? Simply, you are in your class. There are 60 members, maybe probably 50 or from 50 plus members. All 50 members are not coming to classes from one single home. Everyone has their respective homes, and everyone starts from there, from your homes, okay, at respective timings. Maybe by the time you are reaching to the class, you may not sit one above another. You may be sit one after one as per the sitting arrangements. Am I right? See here, you are sitting in the classrooms on the benches that are available one by one, not one above n. That means the energy be once the energy is recorded by sensors, the energy will be recorded with respect to the wavelengths. Hope you understood now. See, the energy always, the light is not in a single constant. Same way, electromagnetic radiation consists different wavelengths. All those wavelengths constitute electromagnetic spectrum. All you, the people, once you reach to the respective classroom, you used to sit as per the seating plan. Hope you understood. Now, how the electromagnetic spectrum being constituted. Now, that is electromagnetic spectrum, and this is what we discussed in the previous class. See, now I'd like to give one more type of electromagnetic spectrum. Don't go there. Don't think that this is different and that is different. Both are same. But if this is the most elaborated and most understandable manner. See here, all these types of lights and all there. Now here, just as like a scale from where to where all the different types of bands are existed in electromagnetic spectrum. See, I know you, and keep in mind whenever we meet in the classrooms, definitely I'll ask all these things. Keep in your mind. Some maybe see here, I forgot sir, something like that. It's okay, that we'll discuss later. But here electromagnetic spectrum. See here, have a look over here. Here all these different types of wave bands are representing here with respect to the wavelength. See here, starting from radio waves, 1 10 power minus 1 1 meter, minus 2 minus 3 mm, 1 micrometers, 1 nanometers. See here, visible light. Here, visible light, you may be heard from your kindergarten, VGR, violet, indigo, blue, green, yellow, all these will be observed here only. I told you that in the previous class with an example of prism. See, once the light is passing through a glass prism, while it is moving to the other end, it will bend according to the wavelength, and all the all different types of wavelengths of the light gives different color. All those color constitutes VGR. Understand? Once again, see, once the light is passing, once we made the light to pass one glass prism, while it enters or while it passes through the prism, while it is coming back to the other end, that has to be bent. And it will bend according to the wavelengths. Right? It will bend it with the different wavelengths with the different color representation. That color representation is nothing but VGR, violet, indigo, blue, green, and orange, yellow. See here, this is what it will take place here. Visible light 0.4 to 0.7 micrometers. See, you may be observed in the previous two sessions, whenever I am giving you Google form and I am giving you asking you questions, I strictly am following one particular question. What is the band of so and so? What is the band length of so and so? Infrared region, visible region, microwave region. Because in the days to come, when you are going through objective questions, the mandatory question is what is the wavelength of so and so X band? You must remember all these band frequencies so that we can get good scoring. See. And coming to that, see, this is what also we discussed yesterday. While moving, the wavelengths whose wavelength is longer, they have lower frequency, and if they have lower frequency, the energy will be lower. And if they have the higher energy, obviously the wavelength will be shorter and the high frequency will be observed. See here, this is what I mean, this is the basic concepts what we discussed yesterday, and also I just included certain new points today's session with what we discussed yesterday also. Yesterday, what we discussed already in the yesterday previous, I mean, in the previous session. Now here, our new topic is interaction with atmosphere, how it behaves, how it will be when it interacts with atmosphere. Your interaction will be different. See, whenever you are interacting your friend, your attitude is different. Whenever you're interacting your junior, whenever you're interacting your teacher, that means when I'm scaling your attitude with respect to when you meet your friend, when you meet your junior, when you meet your senior, when you meet teacher, when you meet your higher authorities, the interaction behaviors are wide, and interaction behavior is simply different to you, different every time. That's what when EMR when EMR enters into the atmosphere, how it is going to react with the atmosphere, and what is the interaction protocols of this EMR when enters into the atmosphere. I told you that, and already you filled in the Google form how many times that EMR enters into how many times the EMR passed through the atmosphere, and in the Google form you maybe encounter that question during, I mean, when you are attempting multiple questions, multiple answers. See, probably you know that whenever the sensors are initiated by the other authenticated people, the EMR starts, electromagnetic radiation comes or is started, and it will hit the target as per your requirement. That means one time. After hitting of the target, the same EMR has to go back to the sensor. That means two times that EMR is passing through the atmosphere, one up and one down end. See, that means both the times when it is being traveling, there might be some incidents, there might be some instances which may take place, which may influence the electromagnetic radiation. Somehow you started in your at your home and to college. If you are at your college, and you need to come to college by passing two of your friends. Let us think that, let us assuming that to come to college you need to pass two what I can say is two of your friends' homes. At first home, you may be you may got the information your friend is not coming to college today. That influence is recorded in your mind, maybe not to everyone, most of the people nowadays. And after that, somehow you convinced yourself and you started to go to college even from that particular station. And coming to the next station where one of your other friend is surviving, your friend home is there, and there also we came to notice that the other friend also not coming to college. And that is also recorded in your mind. Suddenly at the time when you are reaching to college, you remembered assignment of so and so first hour. Simply your direction will be back to your home or wherever you want to go. That means the traveling path is being influenced by what? Whether you are coming to college or not. Understand? In the same way, when the EMR enters, when the EMR hits the target, as well as the sensor records EMR, it purely depends on the atmospheric constants that are lies in the open atmosphere. If the atmosphere is clear, obviously the EMR will be recorded by the sensors, the image will be good. If your friends are already started to college, you may have no second thought, you may reach to college. See here, this is an example. Don't fix and don't write the same thing in your examination sheets. I want to give you more understandable manner so that we can understand what is the interaction of atmosphere. That means it is being influenced in the path, in the way. Once it is hitting target, and if the atmosphere is full of some pollutants and full of some gases and full of some other things where the MR cannot penetrate more clearly when compared to when the clear atmosphere is existed. See, what I'm focusing is here at EMR, definitely somewhere other way it will be influenced by atmospheric constraints. That's the reason we are going to discuss interaction with atmosphere. See here, to hope you see when you are when you are encountering this slide, the first point is when passing through the atmosphere interacts with the suspended particles such as aerosols and clouds, therefore the scattering will be observed. What is this scattering? I told you that once you came to notice that one of your friend is not going to college, the other friend is also not going to college, as your destination is classroom, you are scattered from the college to somewhere else. That means the you have just taken the redirection. You are not your mind is not willing to go to college because you are scattered from your regular path to the somewhere, because whatever influence in the sense, something you feel that one of your friend invited you to attend a function in their home, in his home. You are because you somewhere other way, somehow you are not going to college, as my one of my friend invited me, so I can go to attend his invitation. That means based on the based on the situation, your your path may be changed. See, on that particular day, you have your friend invited to attend the function. You may not, the same reason may not applicable every day. You may not go every day to his home. Whenever you're not going to college, your mind may not turn to go to his house. Even if you go to house, the doors will be closed. The doors may close, and you may be you may not allowed also. See, because on that particular day, as we are not going to college, your mind go to attend go to a certain function halls as your friend has invited you. In the same day or in some other day, your path may not lead to the same direction because you are not invited by so and so one, so and so person who invited in the past. In the same way, the scattering is not what is not same for every time. It depends on the atmospheric constants. Your redirection of path not every time to the invitation of your friend, because it depends on, it is in a situation oriented. It depends on the atmosphere constants, the intensity of atmosphere constants. If one particular day the suspended particles are more, then the direction will be changed into the into a convenient way. See here, I'd like to show you one diagrammatic representation here. When you observe here, see here, from here the light is passing the from the target, from the target, EMR is passing to the, passing towards the sensor, because it here it encountered certain pollutants, so it gets scattered. Actually it has to go to like this. It has to recorded by sensors in the way, but here it encountered and the light scattered into different direction. Let us assume that you are started here at your home. By the time you come here at this particular point, your friend is not coming to college, and somehow you managed yourself, and coming to second also the same answer you got, and by the time you reach to college, your minds are scattered wherever you want. Even you can attend all these type of works without going to the real direction. See here, this is the example. The sensor, the EMR has to be recorded by the sensor. But what happening here, because of the aerosol concentration, the light is being scattered. What it consists, the EMR consists the image of the target. This reflected energy consists image of KHIT. But it is not the recording by the sensor because of the atmospheric constants in Chodavaram not allowing EMR to record the sensors the way that is released from the target, because in that particular point the pollutants are more heavy, or as the pollutants are more, they won't allow you the EMR, the same concentration of EMR to pass through them that is going to be recorded by sensors. That's what happening. See, what are the different types of scattering that we may observe when EMR is passing through, that we are going to discuss in the name of interaction of atmosphere with EMR. See, that's what I said that. See here, if the EM see 100 in the total 100% of intensity, as it is being influenced by aerosol particles, if 80% is recorded by the sensor in the image, they may lose certain portion of the image, or else even the image comes, it may gives blur, it may gives haziness in the sense the image may not be clear. See, that's what that's what you're you are visualizing the PPT. We are visualizing the screen here. Most particularly, See, the solar radiation scattered through the atmosphere towards sensor before it reached the ground causes appearance of haziness to the images. See here, most particularly the solar radiation scattered through the atmosphere towards the sensor before it reached the ground causes appearance of haziness to the images. Before, see, before EMR reached to the sensor, some amount of solar energy also will be recorded by the sensors. The recorded solar energy that influenced EMR electricity, EMR energy will be influenced the recorded image, and the image will be blurred, or image will gives haziness in the sense nothing clear. Sometimes you may be observed if one disco party is going on, one particular club party is going on, and you may be encountered, you may be visualized people are dancing and doing something else, and people are dancing and rhythmic dancing will be, you may be observed, but you may not identify who is dancing and whose that face is and who is dancing over there. That means you are unclear to recognize the images. In the same way, the solar light already recorded by the sensors and the EMR also recorded by the sensors, which is already influenced by aerosols, the image will be blur and image will not give the clear information. See here, there are, what are the types of this atmospheric scattering? There are two types of atmospheric scattering. One is selective scattering, the other one is non-selective scattering. Here, the selective scattering, what is the selective scattering? Here, selective scattering, again, it has been divided into two types, Rayleigh scattering and Mie scattering. What is this Rayleigh scattering? You may be observed, and by the name itself, you are visualizing, you can understand what is happening and what is being influenced, okay, to the EMR. Simply, Rayleigh scattering is primarily caused by, and that means when the EMR is influenced by the gases like oxygen, nitrogen, this type of scattering may be observed. See, understand what I'm speaking is here. See here, the EMR which is reflecting back to the sensors, if it is being reflected by oxygen, nitrogen molecule, it is called as Rayleigh scattering. When you are started at your home, your mind is diverted. Instead of going to college, if your mind is diverted to go to nice movie, that is so and so movie scattering. Am I right? Whatever the name you want to call to that type of scattering. But here, if the EMR is scattered by the gases like oxygen, nitrogen molecules, what is molecule? You know what is molecule and what is atom, because you are, we have very good foundation. Okay, in intermediate, probably you know that. See here, what is molecule and what is atom? Probably you know what is molecule and what is the difference between the atom and molecule. See here, when the diameter of molecule at least 0.1 times smaller than the affected wavelengths. See here, EMR is being stored by sensors, almost 100 times we discussed. That energy is recorded by wavelengths. If the recording wavelength is, see here, influenced by what? The effective diameters of at least 0.1 times of smaller than affected wavelengths. Understand? See, the diameter of the particles is at least 0.1 times smaller than the EMR, which is going to be recorded. This type of scattering will be observed. Where it is observed mostly, where it is observed. See here, the going and diverting from classes, your friends are influenced there. But the same facility may not be applicable to people who are living in the hostels. Probably you know that. They need to go to the hostel somewhere other way, because there is no such type of traveling distances. There is no, the same, the example may not be applicable to everyone. See, that means what I am speaking is here, this scattering will be observed, or as this scattering will be observed at an altitude of 4.5 kilometers. When I'm giving the example, you started from home to college, the hostels may think that I may not travel and I may not encounter all these things, because the same as some examples may not applicable to everyone, but you must understand the concept, what lies and with what perspective the example is being discussed here. See here, the Rayleigh scattering, probably we may be observed that when it is going to be taken place, when the altitude is above 4.5 kilometers. What is altitude here? Altitude here in the sense nothing but height with respect to this topic. Understand? When the altitude, this type of scattering will be observed above 4.5 kilometers when the atmosphere is pure, and the particles of 0. At least smaller than 0.1 times of oxygen and nitrogen molecules. Probably you understood. That is why this is also called as molecular scattering. Once again, there are two types of scattering. One is selective scattering. In the selective scattering, again it has two types. One is Rayleigh scattering, where the EMR is being influenced by the molecules of oxygen and nitrogen. When the oxygen and nitrogen molecules must be at least 0.1 times smaller than the wavelength when we compared with the smaller than the wavelength of EMR that is going to be recorded by sensors, which has the image of target. Understand? Once again, when this takes place, see, you understood that. You understood that. See here, you understood that the EMR is influencing by nitrogen and oxygen whose size is at least 0.1 times smaller than the wavelength of the EMR, and mostly will take place at the region of above 4.5 kilometers, influenced at an altitude of 4.5 kilometers. Okay. Here one more thing is the amount of Rayleigh scattering is as the result invisible ultraviolet radiation is greatly affected by Rayleigh scattering. That's what you are visualizing in the scale. See, the amount of Rayleigh scattering is, see, result of invisible ultraviolet radiation greatly affected by Rayleigh scattering. See, this is also influenced by the amount of ultraviolet radiation that is existing in the atmosphere. And one more thing is Rayleigh scattering can be called small particles, small particle scattering. Invisible light, blue wavelength at 0.5 micrometers is scattered 5 times as the red wavelength at 0.6 micrometers. What I am concluding with this point is probably this type of scattering will be observed at blue wavelength 0.4 to wavelength at 0.64 micrometers. Immediately observe that what is the wavelength of visible band 0.4 to 0.4 to 0.7 or 6 or 9 or 10. Have a look over here. That's what I used to keep all the previous class slides also. Visible band. What you are observing here, blue, red, green. What is the band width here? 0.4 to 0.7. See, observe here where it is simply Rayleigh scattering can be called small particle scattering in visible light. Invisible light. See here, visible light, what is the range 0.4 to 0.7. What it was there, what it is calling as VIBGR, I told you that. See, there violet, indigo, blue, green, yellow, orange, red. See here, blue wavelength 0.4 micrometers is scattered 5 times as the red wavelength at 0.6 meters. Rayleigh scattering will be observed over there. And the second one is of course, with respect to the, quantity of intentions, the quantity of intensity is 5 times. And see here, one more thing is here, invisible light, blue wavelength at 0.4 micrometers is scattered 5 times as the red wavelength at 0.6 micrometers. See here, and hope you understood about this point. And the second one is Mie scattering. Mie scattering in the sense, the previous one is molecular scattering, and now the followed one is Mie scattering. These two are the part of, or as means these two scatterings comes under selective scattering. What are the types of scattering? How many are the types of scattering? Two: selective scattering and non-selective scattering. See here, Mie scattering. Here, Mie scattering, also named as non-molecular scattering, it occurs. See here, that have mean diameters from 0.1 to 10 times larger than the wavelength under consideration. See, at least in the previous case, at least 0.1 times smaller. And here, this one is, see here, have a look over here. The Mie scattering have mean diameter from 0.1 to 10 times larger than the wavelength under consideration. When the EMR is being influenced by the molecules, or as by the atmospheric constituents whose diameter is at least 0.1 to 10 times larger than the wavelength of EMR, this type of scattering will be observed. See here, Mie scattering can be called as large particle scattering because these are the particles which are influencing EMR, which are larger than 0.1 to 10 times to the wavelength of EMR. That's what we can call it as large particle scattering. And this is the important Mie scattering again is include water vapor and particles of smoke, dust, etc. What are the examples? See, what are the examples whose diameter is almost 10 times larger than the EMR? I want to, here I just given the example, water vapors in the atmosphere and smoke, dust in the atmosphere. We are redirecting the path of EMR, which is supposed to be recorded by the sensor. And the influence of mic scattering is most affected in the lower part of 4.5 kilometers of atmosphere. That is, in the previous instance, we have seen that it is happening where it is happening, say, influencing at the altitude above 4.5. Here, what we observed here, affected in the lower part, lower 4.5 kilometers atmosphere. Mic scattering influences large radiation wavelengths than Rayleigh scattering. The wavelength of mic scattering is here. See here, one more point is here. The mic scattering influences larger than the wavelength and the Rayleigh scattering. And the next one is what I want to convey is here, it is larger than the Rayleigh scattering, and the followed by non-selective scattering. And what's happening in this non-selective scattering, we'll discuss in the next class. Probably today we have seen that how the EMR is getting interacted, how the EMR is being interacted in the atmosphere, and how the influence, how it is being influenced, and what happens when it is influenced. um, what happens when it is influenced, what are the different atmospheric constants that are influencing this EMR. We just discussed in the name of interaction with atmosphere. In the interaction of atmosphere, we have seen two types of two mechanisms. One is selective scattering and non-selective scattering. The fundamental reason for this scattering is due to the presence of suspended particles, aerosols, and clouds. Based on the size of this atmosphere this atmospheric constants, we have been divided it as into two types: selective scattering and non-selective scattering. In selective scattering, and there are two types. One is Rayleigh scattering, other one is mic scattering. Because of the scattering of the light, which is supposed to be absorbed by the sensors, the image may get the blurriness, or the image may be hazy, gives haziness to the images, through which we cannot interpret the all the characteristic features of the target, what you want, or whatever is required. Hope you understand about this atmosphere scattering. First part is over, and next part is non-selective scattering. Here, non-selective scattering is nothing is there here. See, it happens when the lower atmosphere contains suspended aerosols. The aerosols should have diameter at least 10 times larger than the wavelengths under consideration. There in the previous case, we have seen that 0.1 to 10 times. Here, at least 10 times larger than the wavelengths under consideration. The important scattering agents here. See, in the previous instance also water vapor, and here also water vapor. But the difference is there with respect to size. Water vapor, water droplets, crystals in the clouds and fog, whose diameter is at least 10 times larger than the EMR wavelength, we can call it as non-selective scattering. Non-selective scattering impact almost, it shows its impact almost on all spectral bands seen. And in the previous case, we have seen it shows its impact on visible, at most particularly at red and blue bands. And this non-selective scattering here, it may be observed because of the atmospheric constituents whose diameter is at least 10 times larger than the wavelength of EMR. This type of non-scattering may be observed, and we named it as non-selective scattering. And tomorrow we will discuss about this non-selective selective scattering in a more detailed manner. Let us go through what we discussed so far. We discuss we again discuss, we just interconnected to the previous session what we discussed, that electromagnetic radiation, electromagnetic spectrum, the other model of the other type of electromagnetic diagram, what we discussed with respect to the scaling of different bands we discussed, and we entered into the interaction of atmosphere, how it is, and how it is being scattered. Tomorrow we'll discuss the following, we'll meet in the followed session. Thank you. Thanks a lot. If you have any doubts, you please contact me in the domain, whatever you feel flexible. Thank you.